In this lesson, we're continuing our study of functions, and we're going to focus on what happens when you combine one function with another. We have 4 different ways to combine: addition, subtraction, multiplication, division. And when we read these, again, remember that this here is read as f plus g of x. This is not multiplication. This is function notation, f of x, g of x, or f plus g of x. When we see this symbol here, f plus g of x, that means we're going to take the entire function f and add it to the entire function g. I'm just going to jump in right away and look at an example of this so you can understand what I'm talking about. We're going to use some colors here. So here is the f of x function. G of x function. And when we say f plus g of x, we're going to start with that. And look at your chart up above here. That means the output of f plus the output of g. So in place of this guy, we're going to replace that with the entire f function, negative 2x plus 6. And in place of g of x, we're going to replace that with the entire g function. And now we simply combine like terms. Negative 2x plus 5x is positive 3x. Positive 6 minus 7 is negative 1. So f plus g of x is 3x minus 1. It's a brand new function. It's a combination of the f and the g functions together. Another way that we can combine is with subtraction. So f minus g of x is when you take the f function subtracting the g function. And again, substituting the entire f function, so negative 2x plus 6, and the entire g function, 5x minus 7. Something special to watch out for here is that you are using a subtraction sign. We need to make sure that you're subtracting the entire g of x function. So, parentheses, so that you know that that minus sign gets distributed to everything in here. Okay, and simplify, so negative 2x plus 6 minus 5x, minus times a minus is positive 7. So we get f minus g of x equal to negative 7x plus 13. Another way to combine the f and g functions. All right, we're going to try a couple more examples just like this. F plus g. So f of x plus g of x. Substitute. 5x squared minus 4x and 3x plus 1. When we combine like terms to this, remember that like terms must have the same powers on their variables. So there's only one x squared term, so that one stays on its own, 5x squared. Negative 4x plus 3x is negative 1x plus 1. So f plus g of x equals that. And then a subtraction one. F of x minus g of x. And again, we're going to use parentheses here because we're subtracting the entire g of x function. I want to make sure that that negative gets distributed to all parts of that 3x plus 1. So we simplify. And combine like terms. There we go. That's adding and subtracting functions. We can also multiply and divide functions. So for some examples here. Two new functions, f and g. we're asked to multiply and divide. So f times g of x means take the f function times the g function. Now, something that we need. The way this is written, just as it is, by substituting, that looks like we're only combining the -5 with the 2x, right? Think about PEMDAS. It looks like just these two. But that's not true. I want the entire f function times the entire g function. So we need to put parentheses around here to remind us that we're distributing all the different parts. So this is just like foiling. We're going to take the 6x squared to everything within this one here. 6x squared times 2x, so 12x cubed. Remember x squared and x cubed. 6x squared times -1. Then we're going to take the 7x times everything in the second parentheses. So 7x times 2x is plus 14x squared, and then times -1. And then lastly, this -5 times both the pieces in here as well. So -5 times 2x, -10x, and -5 times -1. Combine like terms. So -6 plus 14 is positive 8x squared, -7 minus 10 minus 17x, and then plus 5. So f times g of x equal to this. Now, when we go ahead and we do the division side, this is the same as saying f of x divided by g of x. The good news for us here is that our f of x, 6x squared minus 7x plus 5, divided by our g of x. The good news is that we haven't yet learned how to divide these two. So for right now, you get to leave them the way they are. You get to leave this function over this function. Later in the year, we'll learn how you divide things with x's inside of them and x squareds and all that fun stuff. But for right now, you get to just leave it like this. So f over g of x is this. Now, we do have to watch out for our fraction. Remember, the bottom or the denominator of a fraction cannot equal 0. So we need to add that restriction at the end. Remember that word from before, restriction. So say 2x minus 1 cannot equal 0. Okay. So examples 4 and 5 look a little different. We're still asked to do combinations like addition and subtraction, but now notice that we have these. There's actually numbers now instead of x's. So what this means is that we're still going to do the same thing as before. We're still going to do f of x plus g of x, get an answer, but then we have to plug in a 10. Remember that this does not mean multiplication right now. This is f plus g of 10, f minus g of 3. This is function notation, not distribution. So let's start with our first one here. F plus g. We're going to go ahead and start with just an x the way we normally do. So this is f of x plus g of x. Substitute in what we have. So this is negative 2x plus 6. And this is 5x minus 7. Combine like terms, so we get 3x minus 1. But now we're going to come in and say, okay, that is f plus g of x. But what happens when we substitute a 10? So we're going to say 3 space minus 1 and place in that 10 there. Now we get 3 times 10 is 30, minus 1 is 29. So f plus g of 10 equals 29. So same work as that we did before. until once we get this, then we came in and we plugged this in. Now we actually have an input answer, and we get the output. So an input of 10 gives us an output of 29. Now some of you may be asking, Ms. Hanson, isn't there another way I could do this same problem? Couldn't I do this? Couldn't I write f plus g of 10 and start with f of 10 plus g of 10 and just start right away with my 10s? Absolutely you could. So remember, your f function is -2 and your g function is 5. You can plug in this 10 right away, right here. And if we do that, we get -20 plus 6 plus 50 minus 7, -14 plus 43, which is -29. So we still get f plus g of 10 equals 29. Whoops, that is a positive 29. Okay. Both of these ways work. Both of these ways are just fine. Use whichever one makes the most sense to you. If you like doing it all the work with x's and then plugging in your 10, that's great. If you like to start with 10, go ahead and start with that, plug it in. But you need to choose a method and then do your work like this way, way 1, or way 2. Now, we're going to do the f minus g of 3 here really quick. So I'm going to erase all this work here. Okay, so now for f minus g of 3, this is the same as saying f of 3 minus g of 3. So this would be -2 space plus 6 minus, remember I'm going to need parentheses here because I'm subtracting the entire g function, 5 space minus 7. And then if I slip in my 3, then I simplify. Think about PEMDAS. 5 times 3 is 15 minus 7. 15 minus 7 is 8. So I have -6 plus 6 minus -6 plus 6 minus 8. So cancel, cancel. F minus g of 3 is equal to -8. Second example like this. F plus g of -2 is the same as f of -2 plus g of -2. -2 plus 6 and 5, and we're going to substitute in -2 and -2. Simplify, so positive 4 plus 6, -10 minus 7. So we get 10 minus 10 minus 7, cancel, cancel. F plus g of -2 is equal to -7. Remember, this is your input right here, and this is your output. F minus g of 0. So f of 0 minus g of 0. -2 plus 6. Whoops, and this needs to be a minus. Remember, big parentheses for this one, so it goes to everything. 5 space minus 7. And then come through and substitute in your 0. Alright, 5 times 0 is 0, so this is just -7. And then negative on the outside. This becomes just 0, so 6. Negative times a negative becomes a plus, so we get f minus g of 0 equivalent to positive 13. Those are all your algebraic ways to combine functions and combining them with actual numbers. Here's the graphical way. So on page 9, you see that you have f and g as graphs. Over here, rewrite this to be f of 3 plus g of 3. Look at your f function. F of 3. So here's 3. What is f at 3? It's 5. There's your dot. Excuse me. What is g of 3? Here's that 3. G of 3 down here is negative 5. 5 plus negative 5 is 0. So f plus g of 3 is 0. Another one, f of negative 8 plus g of negative 8. Look at your graph. Find negative 8. F of negative 8 right here is 7. G of negative 8 right here is negative 4. So we get positive 3. Let's go ahead, let's do some subtraction ones. F minus g of 5, so f of 5 minus g of 5. F of 5 right here is positive 6. G of 5 right here is negative 5. Remember that a negative times a negative makes it a positive, so 6 plus 5 is 11. So you input a 5 and your output was an 11. These are also outputs. These are your inputs. All of those are inputs. Let's do another one here. F of 0 minus g of 0. So at 0, here's 0, f is a 6, and g at 0 is a negative 5 again. So we get 6 plus 5, which is also 11. Now let's try some ones that have multiplication and division. So f times g of 1 is f of 1 times g of 1. Looking at your chart, we see that f at 1 here is a positive 7, and we see that g at 1 is a negative 5. 7 times negative 5, negative 35. Here's another multiplication one. F of negative 4 times g of negative 4. Negative 4. F is 7. And g at negative 4 is negative 7. So negative 7 times 7, negative 49. And some division. This one here is f of 7 over g of 7. F over 7 is 6. And g of 7 is negative 4. So 6 over negative 4, we get negative 3 halves is f divided by g of 7. And then this one here, f of 0 over g of 0. Now, some of you might be saying, wait, Ms. Hansen, I thought you said you can't have zeros in the bottom. You're right. But this is not a 0. This is g of 0. Look very carefully at your graph. When you look for g of 0, that is a negative 5. So this is equivalent to a negative 5 on the bottom. It is not equivalent to a 0. So it's okay. G of 0 is different than 0. F of 0 is a 6. So this is 6 over 5. Or we say that we get negative 6/5 for our answer. Okay. So that's function combinations and looking at it algebraically and graphically.